Okay, so this problem just asks for the vertical asymptotes, but let's talk about the entire graph as long as we have an example here that we can use. So if I'm looking at this problem, the first thing you should always do is see if you can simplify it all. So if I did the numerator, I believe that's x minus 7 and x plus 5. You can check that for factoring if you need to. X times x squared, negative 7x, positive 5x, negative 7x, positive 5x, that's a negative 2x, and then negative 7 times 5. Then down here in the denominator, so down here in the denominator I see, I think it would be x minus 6 and x plus 5. So you have, let's see, the x times x is my x squared, negative 6x, positive 5x. For those two middle parts, that give me a negative x, and then negative 6 times 5 is a negative 30. All right, so far so good. Well, nobody noticed here is the big thing is that those x plus 5s cancel. So our main part of our graph is going to be determined by just these two. And what do we get from those? So the x minus 7 in the numerator, that's the x-intercept when you set that equal to 0. So we have an x-intercept when x equals 7. So like if you were sketching your graph and you got out here to 7, we'd have to have a point on our graph. For the horizontal asymptotes, that's where you look at the degree, the highest degree term on top, highest degree term on the bottom. So that's like a 1, and it's y equals. So if you go up to 1, we know we have a horizontal asymptote in here. And then the vertical asymptote, I always think that word asymptote is spelled funny. The P is sort of silent, so if you're going to pronounce it, it would be asymptote. Anyway, the vertical asymptote is the denominator of our simplified version. So when does x minus 6 equal 0? When x equals 6, right? If you added that 6 to the other side. So we have a vertical asymptote here at 6. Now, if I put 0 in for x, if I have x equals 0 and then evaluate it out, that's the y-intercept, right? So put a 0 in to our original simplified version here, and we have negative 7 over negative 6. So this is like for my y-intercept. So that'd be a positive 1 and a 6th. So that'd be just above, that's just above this line right here, 1 and a 6. So if these are asymptotes, this part of the graph must be in here. Now let's see where we're at if well, we already know if we put in a 7, we're right here. So my other part of the graph is right here. Now don't forget the last piece. Was there something we canceled out of this equation? And that's the x plus 5. So that creates a hole. X plus 5, when does that equal 0? At negative 5 for x. If x were negative 5, our original problem would never still exist because we would be dividing by 0. So when it's left in there, that creates the vertical asymptote. If it canceled out, that's going to create a hole. So I go back to my x of negative 5, if it's right here. I come up here, I put a hole in my graph, and I just erase out the inside of that little hole to basically say there's a break in the graph because I can't equal that or the original problem would not have even existed. Now those holes are really tricky to see if you use a graphing tool like Desmos or a graphing calculator. So you really have to know to look out for the simplified version of an equation and to be able to find these by using your noggin. With that, I think that covers the question. The vertical asymptotes is or are located, there's only one, and that would have been at the 6 in here. We would not have listed this negative 5 as a vertical asymptote. That was a hole. Lots of parts to watch out for in these problems.